All right, so we're going to go through sequence mode today, and first I have a review warm up here. Can anybody tell me which of these is arithmetic? Two plus four plus four plus four. This is arithmetic, okay? And then can we write both a recursive and explicit? Do you remember how to do that? Explicit is on your sheet. So explicit for arithmetic looks like, I think they put the D at the back. Does that sound right? Okay. So what would that look like for this equation? You would say a sub n equals 2 plus n minus 1 times, didn't we say we're adding 4s? Okay. And on the quiz, I would be okay if you left it like that. I don't know what delta math does. I don't really remember. If we distributed this, we'd have 4n minus 4 plus that 2. I think it would be 4n minus 2 if you simplified it. Okay, either one of these are fine with me. What about, though, recursive? Does anybody remember how recursive looks? It has two parts. What are the two things you have to tell me? The first term, and it doesn't matter what order you tell them to me in, but the first term, and you tell me how to get to the next term using the previous term. Remember what the notation is for previous term? A sub n minus 1, and what is this one doing? Adding 4. Elena, can you put your phone away? Okay, guys, we got a quiz on this stuff yet. Lots of you on phones. That's not going to get you through this last summative. Okay, this one, what are they doing? Multiplying by 5, so therefore this is geometric. Okay, so the explicit for geometric on your sheet looks like this. So what would that look like here? A sub n equals 4 times 5 to the n minus 1. And you don't have to have the parentheses. You could just have a dot for multiply here. But can you do 4 times 5 is 20? No. All right, and that's it for explicit. Recursive, you would have to tell me the first term, which is 4, and then you would say to get to the next term, I take the previous term and do what? Multiply by 5. Okay. Paige and I are doing really well. Some of the rest of you following and you're just half asleep, or? All right. Sequence mode on your calculator. First of all, we just revisited this vocabulary. Is this worksheet 7, guys? Okay. A term in a recursive sequence depends on the previous term. An explicit term uses the n and leaves the n in the formula. But just to let you know, the sequences that we're going to use today are not all arithmetic or geometric, and that's when having the calculator really helps, the sequence mode on the calculator. Just cool slide about famous number sequences, square numbers, odd numbers, even numbers. This is Fibonacci's sequence, the one we talked about. I talked about some yesterday with some of my classes. I don't know if I talked about it with you guys. Anybody seen this before? What am I doing to find those? It's not arithmetic or geometric. You add the previous two to get the next one. So 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 would be 21, I think. Okay, that's Fibonacci's sequence. So all kinds of different number sequences. All right, I'm not going to worry about this first. That's a really old school way to generate a sequence on your calculator. What we're going to do first is I'm just going to show you if we wanted the terms of an arithmetic sequence that we had simplified down to 3x plus 2, the most basic way to find the values of that would be just to leave our calculator in function mode and graph it as though it was a line and say y equals 3x plus 2 and just go to the table, and the first value would be 5, the second value would be 8, and so on, okay? If it was a, if we said we're going to do 3 times 2 to the x minus 1, that's not going to be. So here, again, it's generating the terms of the sequence, okay? That's just in function mode. Does that seem okay? But now we're going to try some weirdness. We're going to try putting our calculator. Can everybody grab their calculator and go down to mode? It doesn't matter if you're in degrees or radians because we're not going to do trig today. But go over to sequence mode. So way over here at the end, it says sequence mode. Now, I'm going to apologize now because mine looks different, I think, than yours. Mine might represent, look more like some of you who have brand new calculators. But if you go to y equals, this is what you should have here, sort of. How many of yours says, doesn't show the same thing at the top necessarily, but it should start with n min, right? And then it should say u sub n. And mine says u sub 1, but yours might say u sub n min. Does yours say that? U sub n min? Okay. Whatever you tell it to be the minimum number, the minimum term number, you want to start with term 1, then this is where you put the value of term 1. All right, and that it looks more like, I thought I had it on here. Here, this is the explanation, okay? Does that look more like yours, guys? Is it dark? Can you see that? Can I make it bigger? Okay, so this is the explanation. N min is the minimum term number that we're going to start with. We are going to find some application problems. It works better if we start with like a term 0 instead of a term 1, and we'll look at that in a minute. But for the most part, we're going to put n min as just 1. U sub n is where you put the formula in. You can put either explicit or recursive formula in there, okay? The two that I just did, let me stop and show you those two real quick. One I just did was 3n plus 2. Was that what I did, guys? 3x plus 2 or something? Okay, you would type that in here for the formula, u sub n, and you would use that x key that's underneath the mode button, and it will now be an n. So then if I went to, I would get the same thing, but it would say this is the term number, and this is the formula, the values of the terms. Notice if I go up, it's an error because I told it to start with term 1, so there is no such thing as term -1. The other one I just did, I forgot because I made it up. Was it like 3 times 2 to the n minus 1? We'll pretend it was. Okay, and then I could put that in, and it would say 3, 6, 12, 24. And again, it's not got, you can't have negative term numbers. All right. But the recursive is a little trickier. If I wanted to say, I want to put in the previous term times 2, we'll say. Do you see the U above the 7 on your calculator? The U above the 7. So you would do second and then that u that's on the 7, and then you would say n minus 1. So you're going to do just parenthesis, the x minus 1, which is going to put in n minus 1. So even though it's not a subscript, that's saying the previous term. So if I wanted to say the previous term times 2, I could just do that. Now, when I put in that format, I have to tell it the first term. So, well, yours doesn't say u sub 1. Yours probably says u sub n min. As long as you have a 1 up here, this is where it goes. And you would say, like, I want to start at 3. And now if you look to your table, it's doing that sequence starting with 3. Questions? Okay. So we are going to do some problems here, I think. It says find the 6th term. Now, these are horrible examples. I wish I had done this differently and redid this worksheet because I went to key it yesterday. I was like, these are not fun. But go back to your y equals, and we're going to type this sequence in. It is an explicit form, so you would not need to tell it a first term number. It's going to start with term 1, and you're going to type this in for the u of n right here. It's a weird one. It's 1 divided by, and you would need parentheses to keep the n in the denominator, 1 divided by 2n, and then a plus 2 on the outside after you've closed the parentheses. Now, if we go to the table, so second graph, and we wanted to find the 6th term, you would just go down to term 6 right here, okay? And it won't change it to a fraction, unfortunately. So you just get that 2.0833. Now, I have to tell you, this is an explicit form. So if you want the 6th form, the easiest fastest way to do that is just to put a 6 in. So you'd have 1/12 plus 2. So if you just went to your home screen and you didn't have to do anything fancy and you said 2 1/12, you'd get that same decimal, okay? So using sequence mode was not very helpful, and it's not a pretty answer anyway. So there's what we had, 2.08, repeating. All right, that was not a fun example. The next one I have is in recursive formula, also a disgusting example. I don't know why it's so gross, but go back to your y equals, clear out your formula that you put in. This one has a negative out in front, and then it has a u sub n min. See the formula right here we're putting in, okay? So it's second 7 to get the u, it's parenthesis to make a subscript, and then the x key should be an n now, n minus 1, close your parenthesis. So that's the top of this, and then it just says divided by 3. Now, if you wanted the 10th term of this sequence, it would be hard to find without your calculator because you don't know the 9th term, you don't know the 8th term, you don't know the 7th term. It wouldn't be impossible. There's a formula we could use, but this isn't going to work, though, at the moment. When it's recursive, what else do you have to tell it? To tell it the value of the first term. So either u sub n min or u sub 1, whatever your calculator has down there, you're going to put the 9 down underneath there because it said here term 1 is 9. So now if you go to second graph, it should start with 9. And then basically this is saying divide by -3, divide by -3, divide by -3. Now, the 10th term is disgusting. If you go down here to term 10 and over, it will tell you it's -0.000457. It's just, I don't know why I made that such an awful example. Okay? So I wouldn't worry about what it comes out, but that's how you type in one that's recursive. Ugh. All right, find the 8th term. What is more effective if you want to find the 8th term of this sequence, guys? It's an explicit formula, so putting in an 8 would be the most efficient way to do this. 8 cubed minus 1, all divided by 2. I don't know what that is. Quit. 8 cubed would be 512, so minus 1 would be 511 over 2. That could be the 8th term, or the decimal equivalent of that, but I didn't have to do anything that was time-consuming on my calculator. All right, example 2 says find the 4th term. Now, because it's only 4 terms, it probably would be pretty quick to find by hand. You would say it starts with 7, and then what does it tell you to do here? Take that term and do what? Multiply by 2 and add 5. So 2 times 7 is 14, plus 5 is 19. 2 times 19 is 38, plus 5 is 43. 2 times 43 would be 86, plus 5 is 91 maybe. But because it's recursive, it might be worth our time to put it in the calculator. All right, they told us term 1 was 7. So we're going to need a 7 down here underneath the formula, but the formula says 2 times the previous term. So to put in 2 times the previous term plus 5, we would go 2. Now let me clear this out. 2, second 7, parenthesis, and minus 1, close parenthesis. That's not a distributing, that's just the notation that the calculator uses for the previous term. Then was it plus 5, guys? And the first term was supposed to be 7. So right underneath the sequence where yours either says u sub n min or u sub 1, put in a 7 and then go to the table. And it says 7, 19, 43, 91. So 91 is the 4th term. Not sure it was more efficient to use the calculator, okay, but 4th term was 91. All right, there is no way that the calculator is very efficient at finding sums, okay? So this is a revisit of a formula question. Find the 7th partial sum. So we need the sum of 7 terms, but there's 2 different sum formulas depending if it's arithmetic or geometric on your sheet. What is this one doing, guys? Ew, is it doing anything nice? Let's see, what is it doing? Adding. Ew, that's not nice, is it? Negative 10 divided by negative 22 is going to be 5/11 times that. Ew. It's not arithmetic or geometric, is it? Okay. That explains why it's on here. Well, no, you'd have to generate all 7 terms and then add it up. But you'd have to find a way to write a formula or figure out what it's doing. So what did this do? It added 12 and then 11 and then 10. So plus 12 plus 11 plus 10. So then we do plus 9, which would be 20. Plus 8 would be 28. Did I do that right? Okay, and how many terms are we looking for? 7? 1, 2, 3, 4, 5, 6. Plus 7 would be 35. And then we'd add them up. Yep, gross, not on the quiz. Okay, moving on. Sorry, this is what happens when I don't do the whole lesson ahead of time. This course used to start with a chapter on sequences. Can you imagine the first week of school if I was trying to teach you sequence mode? It's pretty tricky. This particular question is out of our book that had This is not arithmetic nor geometric. It says University of Tennessee State, whatever it says, its current enrollment is 35,000. Each year the school graduates 25%, or about a fourth of their students, and then enrolls a new class of 6,500. What will the total enrollment be 8 years from now? Okay. So there's the current enrollment, we're going to call U sub n minus 1. What is the first thing that happens to that enrollment? The end of the year, what happens? 25% leave. What do we multiply by to show that there's still 3/4 of the students there? 0.75. And then before the next, or at the beginning of the next year, what happens? 6,500 add, right, to the total population. So we're going to put plus 6,500. Okay, this is a recursive formula. Now, there's a trick to this because the current enrollment is 35,000. That is 0 years from now, right? It's not a year from now. So to make this easier, we're going to say U sub 0 is 35,000 rather than U sub 1. Because this is not after 1 year, it's right now. So to find U sub 8 is what we want to find. All right, so let's go to the calculator and go to y equals, and we're going to go up to the top. N min is going to be 0. And I'm going to skip this one and just clear it out and go down here and say 35,000 for our first term number. So even though yours says U sub n min probably, that's where it should be. All right. Then we're going to go back, whoops, and write the formula, which was U sub n min, so second 7, parenthesis, n minus 1, times 0.75, and then plus, was it 6,500? Okay. So that's the sequence. Now if we go to the tables, anybody need more time? Go to the table. This is kind of nice because you don't have to set up a window, right? Everybody's table's counting by ones. If your table was not counting by ones, you would have to set that up under second window, tell it to count by ones. So after 1 year, this is the student population, okay? After 2 years and so on. So after 8 years, we're at 26,901, okay? So the answer to the question, 8 years from now, is 26,901. I do want to show you real quick that when you have this kind of a situation where you're multiplying and adding, it frequently will approach a value after a certain number of years. I'm going to tell my table to count by 5s real quick and show you that eventually, do you see that this evens out at 2,600 eventually? Okay. Just wanted to show you that. All right. The next question says a business makes $10,000 profit during its first year. If the yearly profit increases by $750 in each subsequent year be, what will the profit be in the 10th year? I don't think that's a calculator mode question in my mind. What kind of sequence is that? Increasing by $7,500. It's arithmetic. So could you pretty easily find the 10th term without anything complicated? So I would have just said $10,000 is the first term, plus they are adding $7,500. They want to know the profit in the 10th year, so that would be 10 minus 1 times, we're going to add that. So can somebody type that in? 10,000 plus 7,500 times 9. Okay. That's the answer to the first part. The second part of the question says, what is the total profit for the first 10 years? Arithmetic sum. Do you remember that formula at all? It's on your sheet. The sum of the first 10 terms when it's arithmetic is the one where you do what? Number of terms divided by 2 times the sum of the first term and the last term. Does that look familiar? Where n is going to be 10. So we would have 10 over 2 times 10,000 was the first term plus 77,500 was the last term. Now if I type in that my calculator with the right number of zeros, I got $437,500. Putting it all in the calculator in sequence mode, I show you here how I would have typed it, the previous term plus 7,500 times 10, or starting with the first term of 10,000. That would have helped me find the 10th term right there, 77,500, but it wasn't going to give me the sum anyway, right? Unless I added all those years up. All right, couple more examples. This is actually a little more complicated version of a quiz question. The quiz question is not this complicated, but this is a good application. A lecture hall has 6 seats in the first row, 8 in the second row, 10 in the third row, and so on through row 12. Then after that, all of the seats have the same number of rows for rows 12, 13, 14, 15, 16, 17, 18, 19, and 20. So there's 9 rows that have the same amount. So you could use the formula we just did. You could say 6 plus 2 to the 12 minus 1. If you want to practice with the calculator one more time, we would say row 1 had, was it 6 seats, guys? So go down here and put in your first term was 6. And then go back up here and say the previous row, which was U parenthesis n minus 1. And it just, did it go up by 2? Is that what we were doing? Okay, so plus 2. Then if you go to the table, so second graph, what does row 12 have? 28. So this kept going up to row 12 had 28 seats. Now, we can add this sum. They want the total number of seats. So the calculator helped us a little bit, but to find the total of those, we would say the sum of those 12 rows is 12 divided by 2 times what? Because it's arithmetic. So the first term was 6 and the last term was 28. Anybody get 204? Now, we have a little trick to this question. I already added row 12, right? So we have left 13, 14, 15, 16, 17, 18, 19, and 20. 8 more rows. And each of those 8 rows has how many seats, it says? 20. All have the same number of seats, so they all have 28. So we have 8 more rows that each have 28 seats. So that's the final answer for this, and I would not ask it that complicated on the quiz. 428, anybody? All right, I think we have a couple left, and I really like number 9, but we'll do this one quick because this is an example again that is neither arithmetic nor geometric. Suppose a flower nursery manages 50,000 plants and each year they sell 10% and then they plant 4,000 new ones. Do you see how that's like the first question we did about the school population? So they start with 50,000 plants, and then they take that amount and they do what to it? If they sell 10%, how many remain? 90%. And then they plant 4,000 new ones, so what do we want to do there? Plus 4,000? Okay, now the trick comes with, if we want to say this has 20 years from now or after 20 years, is this 1 year from now? 50,000 is not 1 year from now, right? So we're going to call it term 0. Yep. So to put it in our calculator, we're going to go to y equals, and you at no point on the quiz do you have to be in sequence mode, so you will never have to worry about, do I call it term 0 or term 1, okay? Don't worry about it. 50,000, and then we put in u sub n minus 1. Wasn't it 0.9 times 0.9? Whoops, not 9. 0.9. And then plus 4,000? Okay, so we have to go out a ways. My calculator scrolls really fast because it has the power of the computer behind it, but for yours to scroll to year 20, it might take a minute. Wasn't it year 20 they wanted first? So I have, by the way, it's an ugly decimal. If you look down at the bottom here, but it's a number of plants, so we just want a whole number anyway. So 41,216, did someone else get that, or did I type something wrong? Okay, so the 20-year mark, I think I have it here. The 20-year mark, we were at 41,216. And then anybody scroll out to 35 yet? Yep, that's what I have. And if you kept scrolling, again, this is one of those where you would eventually notice it doesn't change. It's what kind of, the term in science is it reaches equilibrium eventually, okay, where it doesn't change. All right. What is this one? All right, let's see if we can do this one without the calculator quick. A monument is constructed by laying a row of 60 bricks. A second row, 2 fewer, so 58. Third row, 2 fewer, and so on. The top row has 10 bricks. Oh, you know what? This is actually handy to use the calculator. So we want to say the first row had 60. We could do this without the calculator, but it's kind of fun. The first row, so I'm going to put a 1 in here. And then after that, the first row had 60, so go down here and say 60. And then the sequence is second 7, n minus 1 in parentheses. And then what was it doing, guys? Going down by 2, is that right? So minus 2. And it says the top row has 10 bricks. So we want to know what row number is that? When does this get down to 10 bricks? Whoops, it's not row 80. The top row has 10 bricks. That is row, I have 26. Did anybody get row 26? Okay. And I could show you how to do that without the calculator. 1 second. So row 26 had 10 bricks. Without the calculator, you would have had to say, I'm down to 10 bricks. The first was 60. I'm subtracting 2, n minus 1 times, and I don't know how many times I've subtracted. So then you would distribute and simplify and solve, and that would be 26. All right, back up over here, though. We want the sum. What kind of a sequence is this? arithmetic. So to find the sum of 26 rows, you take 26 divided by 2, first row plus last row. $910, anybody? All right. So sometimes sequence mode is helpful, and I used it to check a couple of my answers when I was keying the quiz, but it's not something you have to know how to do. The formulas will work. All right, love this last question. If you're paid a penny a day for the first day of March and your salary continues to double each day, how long will you make in the month of March? The calculator is not going to give us the total, but it'll show us what we're making each day. So quickly go to your sequence and you're going to say the first day you're making a penny. So this would be 0.01. And your formula, you want to say each day it is doing what? Doubling. So we say times 2. U sub n minus 1 times 2. Okay, look at the table. It's not very exciting the first week, right? Okay, I'd want to quit after the first week. But should you quit? If you, second week still, day 14, you're only making 81 bucks, considering your total is not very much. But look at day 20, you're up to $5,000 for one day of work. Go out to, how many days does March have? 31. Does anybody look at that number? If you move your cursor over there, what is that number? On $10 million. $10 million on the 31st day, starting with a penny. Okay? Now, if we want the total that you make, what kind of a sequence is this? It's geometric. What is the geometric sum formula? Does anybody remember? That's the one we just learned yesterday. The sum of 31 days. It looks like this. Does that sound familiar? Okay, so what is our a sub 1? A measly 0.01. What is our r value? 2. And n is 31 days. Okay, and then we're going to divide that all by 1 minus 2. Okay. 0.01. Now let me do it on this calculator for the shock effect, right? Quit a penny times 1 minus, and you really don't need the extra parentheses on this particular one, but I'll put them in, to the 31st. Arrow to the right, close that parenthesis, divided by, you need parentheses around the denominator, 1 minus 2 again. Boop. So $21 million in the month of March. Maybe it would be worth it? Love that question. Fun, huh? Okay. Let me put that one on the screen so that total is there. Okay, so I have no real additional work tonight. You need to finish up your Delta Math from yesterday, and the next day, tonight and tomorrow, you're going to be doing the rest of this packet. But let me tell you, on worksheet 8, just in case you want to get started tonight, I would suggest maybe you just do these 5 tonight. On worksheet 8B, the only ones I want you to do are 4 through 9, okay? I don't know what I was thinking. The ones at the top of that worksheet are miserable. Just do 4 through 9. So circle on 8B, 4 through 9. If you want to go beyond that and work on 9 and 10, that's what we're going to just give you time to do in class tomorrow. There are a few I'm going to X out on 9 and 10 as well. How much time do we have left? I'll stop the video, but...